Hello everyone, in this video we're going to talk about trigonometric integrals. So what happened with trigonometric integrals is that we can use some trigonometric identities to integrate certain combination of trigonometric functions. And then we can make use of integration by parts to help us transition some difficult and complicated integrals to something that is going to be much more simple. So first, let's start with some integrals of powers of sine and cosine. And then later in the second part of this section, we're going to be talking about the rest of the trigonometric functions. So as an example, let's consider the integral of sine to the 5x times cosine square of x. And notice that we have the main trigonometric identity, which is cosine square plus sine square equals 1. And we certainly could try to convert this cosine square to 1 minus sine square of x, but that won't really give me anything special or anything that I can manipulate between function and derivative. This just give me something like sine to the 7 minus sine to the 5, which is not going to be really good. So instead, we're going to separate a single sine, and we're going to rewrite the remaining sine to the form in terms of cosine. So we can use either integration by parts of some sort of substitution. So for example here, notice sine to the 5, I can see it as sine to the 4 times sine, right? Sine to the 4 times sine times cosine square. And now sine to the 4, I can see it as sine square is square. And so now sine square can be transformed to 1 minus cosine square. So with this, we have that sine to the 5 cosine square of x becomes 1 minus cosine square of x squared times cosine squared times sine. Now you can see where this is going, and this is going towards a substitution, because if we make u equals cosine of x, then we're going to have du is equals minus sine of x dx, and we already have one sine of x that is single here, so we can use it to get the substitution factor du. So now if we integrate, and we have here replacing u equals cosine of x, this transforms into u square times 1 minus u square square times minus the u from minus sine of x dx here. Now if I plug out that minus, and that's going to give me the opportunity to multiply this factor. So first, this is going to be the first one is square minus twice first by second. So it's going to be 1 minus 2u squared minus u to the 4. But multiply by u squared, this is going to give me u squared minus 2u to the 4 plus u to the 6. Everything now here is in terms of powers, so it can be much more easily manipulatable. And we can use just a basic antiderivative to find out that this is u cubed over 3 minus 2 u to the 5 over 5 plus u to the 7 over 7 plus c. And then we can replace to the original variable that it was u being cosine of x. And so we get the result in terms of cosine of x. So this is one of the approaches that we can use with trigonometric identities. Indeed, sometimes we can just basically go ahead and write one of the identities in terms of a different trigonometric identity. For example, we have the integral between 0 and pi of sine square. Yeah, sure, 1 minus cosine square will be a transformation, but this is not much more simple to evaluate. So instead, we're going to use the half angle formula for sine square. And if you want to think about what the what the half angle formula is that essentially sine square can be seen as 1 minus cosine of 2x divided by 2. And so that what that makes is that sine square of x, the integral from 0 to pi of sine square of x, can be seen as 1/2 of the integral from 0 to pi of 1 minus cosine of 2x dx. And that's going to be integrating this is of course going to be 1/2 of x minus 1/2 of sine of 2x. And then we can plug this between 0 and pi. Remember, the integral of cosine of 2x is something that you do with a small substitution, and the antiderivative of cosine is sine, and so that's why you get minus 1/2 of sine of 2x. Now, if we plug these values, we're going to get that this is 1/2 of pi minus 1/2 of sine of 2 pi, and minus 1/2 of 0 minus 1/2 of sine of 0. This gets to be 0, and this becomes 1/2 of pi. Now, of course, we can't mentally make the substitution u equals 2x when we're integrating cosine of 2x here, but it depends of your mileage doing substitution, if you're capable of doing this right away, or you might do it step by step. I recommend that you take a look at the substitution review videos if necessary. Now, to summarize, we can kind of list a number of guidelines when we're evaluating integrals of the form sine to the m times cosine to the n of x, where m and n are integers. So essentially, we're going to go for integrals that have multiplication powers of sine of m, cosine of n. The first one is, well, consider what type of powers you have. If n is odd, if the power of the cosine is odd, then you're going to save one of the cosine factors and use one of the transformation of cosine square into 1 minus sine of square of x. So as you can see here, if I can see n a certain number 2k plus 1, I can just see this as sine of m, cosine of 2k plus 1. We separate one of the cosines, and then this cosine square is converted to 1 minus sine square. Why is that? Because then we can use the substitution here, u equals sine, and the du cosine of x dx is going to be next to it, and this is just going to be a power function, a power integral, when we make the substitution of u sine of x. If we have the opposite, if the power of sine is odd, then we save one sine factor and just use the conversion on the other side, and sine square equals 1 minus cosine square. And we do kind of the same thing. Notice sine of 2k plus 1 of x, and so we now keep sine square power to the k times cosine to the n of x. We transform the sine square into 1 minus cosine square. And of course, here the substitution is going to be u equals cosine, and the du is going to be sine of x dx. Now, the other type of trigonometric identities that we can use are the half angle identities. So pretty much we are considered that the sine has half of the angle of our next transformation. We have the sine square can be seen as 1/2, 1 minus cosine of 2x, or we can consider that cosine square of x can be seen as 1/2 of 1 plus cosine of 2x. And of course, this is in a scenario where we can just simply reduce with power functions that are even. So both the cosine and the sine, they have even functions. So with this, we can reduce the power from 2 to 1 by doubling the angle. Sometimes the double angle identity of 1/2 sine of 2x being the multiplication of sine of x cosine of x is going to be useful. And this type of thing will be something that you will see much more examples on the practice videos.